Alright. Okay, good morning, good afternoon, or good evening. No? Depends on when will you watch this recorded video. So for our module 2, rectilinear motion of particles, the first topic is the position, velocity, and acceleration. A particle moving along a straight line is said to be in rectilinear motion at any given instant time t. The particle will occupy a certain position on the straight line. Now, to define the position P of the particle, we choose a fixed origin, say O. Now, O on the straight line and the positive direction along the line. Now, if we set this point as our origin, the next thing we're going to do is to set a positive sense of direction. Now, in this example, in this topic, in this discussion, no, we will set the positive direction going to the right. Alright, so we measure the distance x from O to P and record it with a plus or minus sign according to whether P is reached from O by moving along the line in the positive direction to the right or the negative direction to the left. Now the distance x, this one, with the appropriate sign completely defines the position of the particle. It is called the position coordinate. For example, the position coordinate corresponding to P in figure A is equal to positive 5 meters. Why? Because it is going to the right of O. Now, the coordinate corresponding to P prime in figure B is negative 2 meters. Why? Because it is going to the left of O. So, why 5 meters? Why 2 meters? Because we set our interval to be 1 meter. Okay. Now, also to consider the position P occupied by the particle at time t, the corresponding coordinate x shown in the figure. This is the P. And consider also the position P prime occupied by the particle at later time t plus delta t. The position coordinate of P prime, this figure, the position coordinate of P prime, the same with this figure, ato lang ibalhin sa PCAS, can be obtained by adding the coordinate x, coordinate x of P, the small displacement delta x, which will be positive or negative according to whether P prime is to the right or to the left of P. Now, the average velocity of the particle over the time interval is delta t is defined as the quotient of the displacement delta x and the time interval delta t. So sa units, the units used is meters and seconds if it is SI, international system. Now if US customary units are used, delta x will be expressed in feet and delta t is in seconds, and the average velocity will then be feet per second. The instantaneous velocity, on the other hand, this is the particle at that instant t and is obtained from the average velocity by choosing shorter and shorter time intervals, delta t, and the displacement x, delta x. What does it mean by shorter and shorter? Now if we consider a smaller value of an object. Okay, if this is the particle from this position x, moves to this position, say from origin to P, the distance covered, is delta x. Now the final position P will then be equal to, so say this is the initial position is x, and the time, the distance traveled, by the particle from the origin to the final position P is equal to its initial position plus the distance covered, the delta x. Now, if we choose to choose a shorter and shorter time intervals, that is when kanang gamay na kaayo siya, that is now the time we will consider calculus on solving the instantaneous velocity. Now, for the limit of instantaneous velocity, that is the change of displacement x from final final position minus the initial position over the time interval, no? Where delta t approaches to 0. That is when we consider this shorter and shorter distance. Okay. So, simplify, since this is the same variable x, no? Cancel. So, the instantaneous velocity, delta x, will then be, okay, mauna din siya. Now, since the instantaneous velocity will also be expressed in meters per second, observing that the limit quotient is equal by definition to the derivative now of x with respect to t, we write, so this is now the calculus, the differential of these shorter and shorter time intervals. So the velocity will then be equal to the derivative of x with respect to time. Okay, so what is the difference, no, between the average velocity and the instantaneous velocity? Okay, so we consider this instant, no? Say this particle moves along a straight line from here to here, no? Say the initial velocity is equal to 2 meters per second, and at this point it is 6 meters per second and 4 meters per second at this point. The same particle moving along a straight line. Now, the instantaneous velocity is the velocity of the particle at that certain position of that certain time. So this is the example of instantaneous velocity. Okay? Now, the average velocity, it depends on the time interval. Okay, on how long it took the particle to reach from this point to this point. Say this is, the distance between this point is 100 meters. Okay, and the time it took, no, delta t is equal to 20 seconds. So the average velocity will then be the delta x over the delta time. So the average velocity is, 5 meters per second. Right? Now, a positive value of v indicates that x increases, no? That is when the particle moves in the positive direction in figure A. A negative value of v indicates that x decreases, no? That the particle moves in the negative direction. Alright? So the magnitude of v is known as the speed of the particle. Y speed? Okay? The magnitude of v. Since v is known as vector, the velocity is known as vector. What is vector? Vector composed of the magnitude and direction. Okay, so the vector is magnitude and direction. So for velocity, the magnitude is speed and the direction is either positive or negative. That is when since atong assumption is to the right is positive, so ang direction niya is to the right or to the left. Okay, so that is why the magnitude of v is the speed and the direction is either right or left. Okay, so consider the velocity v again, now of the particle at time t and also its velocity v plus delta v at a later time t plus delta t in the figure shown. The average acceleration of the particle over the time interval delta t is defined as the quotient, okay, quotient of delta v and delta t. So, okay, so the units is the same, no? If it's a units, the units will be meter per second squared for acceleration, and for u is customary units, the units will be feet per second squared. Okay, so the instantaneous acceleration a of the particle at the instant time now is obtained from the average acceleration by choosing smaller and smaller values for delta t and delta v. Okay, it's the same with the average velocity and instantaneous velocity, right? So the instantaneous acceleration will also then be expressed in meter per second squared and feet per second squared. Okay, so the limit of the quotient, which is by definition, no, the derivative of v with respect to t, measures the rate of change of the velocity. We write, okay, the acceleration equal to the derivative of the velocity with respect to time. Or substituting for v, this is a second order of differential equation, no? Okay, So take note on that, no, magamit na nato sa atong example. So this equation, no, will then be useful for our example, the equation 2.2 and 2.3. So the acceleration A is represented by an algebraic number which can be positive or negative, no. A positive value of acceleration indicates that the velocity increases. Okay, this may mean that the particle is moving faster, positive direction, or that is moving slowly in the negative direction. Okay, the arrow, no, indicates the magnitude of the velocity. Pag gamay ang arrow, hinay ang velocity, and dako ang arrow, usog ang velocity. Alright? In both cases, the velocity is positive. Okay? So, a negative value of acceleration indicates that the velocity decreases. Either particle is moving slowly in positive direction, or faster in negative direction. Okay? The term deceleration is sometimes used to refer A when the speed of the particle, that is the magnitude of B, no, decreases. The particle is then moving slowly. Okay, for example, the particle is decelerated in parts B and C. Okay, ito ning padak-an ni deceleration, no? So what is deceleration? Okay, the deceleration is equal to the negative acceleration. Okay, so in this example, the particle is decelerated in parts B and C. Okay, atong i-check sa B. Now sa B, okay, sa going to the left siya, no, usog siya, din hinay P prime. It means it decelerated, no? But the acceleration, no, not all the time, no, not all the time din, no, nga si deceleration is negative acceleration, not all the time. Alright? Ang diri nga instance sa figure B, okay, from say 100 meter per second, ni slow siya, say this is 100 meter per second, do, ni slow siya to 50 meter per second. So that means ni decelerate siya, but the velocity is still positive. Okay, that is why the acceleration is greater than 0. Okay, so for C, since it's B and C, okay, parehas, same lang gyapon siya, ni decelerate siya, same direction. Okay, and also it is truly accelerated, okay, moves faster in parts A and D. Alright, so another expression for the acceleration now can be obtained by eliminating the differential dt in equations 2.1 and 2.2. Solving 2.1 for dt, we obtained, no, since our okay, the formula for 2.1, that is v is equal to dx over dt. Okay, and sa 2.2, that is the acceleration is equal to dv over dt. Now we iterate it in terms of, okay, we alter this equation, no, in terms of dt. So we have dt is equal to dx over dt. Ano, this is v. Okay, so atong substitute diri atong dt. So we have dx over v, that is v dv over dx. So mao ni nga equation. Alright, so that would be all for the position, velocity, and acceleration.